Hello everyone. We are back with another topic. So today we're going to talk about RC phase shift oscillators. So let's not waste much time. Let's go through it. So this is the circuit diagram of the RC oscillator. So before we start, I'll tell you what an oscillator is. An oscillator is a circuit which has no input but generates output or generates sinusoidal waveforms. This is because oscillators have this thermal noise inside them. This thermal noise acts as input for them, and this thermal noise will go through the transistor and produces sinusoidal waveforms of the output. So this is the circuit diagram of the RC oscillator circuit. You can go through it. So the RC oscillator circuit. And for people who are thinking what RC stands for, it's resistor and capacitor. So remember, RC oscillators use a combination of an amplifier and an RC feedback network to produce output oscillations due to phase shift between the stages. So this contains an op-amp which functions as an amplifier. So this amplifies the circuit, and some part of the output goes through the RC feedback. So feedback is something that, let's say, a part of the output is supplied back to the input. So this makes a big this increases the voltage gain for the op-amp or for the circuit for an RC oscillator to sustain its oscillations indefinitely. Sufficient feedback of the correct phase, that is positive in phase feedback, must be provided along with the voltage gain of the single transistor amplifier being used to inject adequate loop gain into the closed loop circuit in order to maintain oscillations, allowing it to oscillate continuously at the selected frequency. So there are two kinds of feedback: positive feedback and negative feedback. So if the feedback is connected to the inverting terminal, it's negative feedback, and if the feedback is connected to the non-inverting terminal, it's positive feedback. And when the input and the output have 0-degree difference in them, then they are said to be in phase. So that's what we see here. The RC oscillator circuit is positive in phase. However, in reality, it is difficult to obtain exactly 90-degree of phase shift for each RC stage. So we must therefore use more RC stages cascaded together to obtain the required value at the oscillation frequency. The amount of actual phase shift in the circuit depends upon the values of the resistor and capacitor at the chosen frequency of oscillations with the phase angle being. So at each RC oscillation, that is at each RC combination, there's a 90-degree phase shift. So you can make an estimation of how many RC oscillations or how many RC pairs you need for the output to be in a zero phase or to be in phase with the input. So this is the circuit diagram. This might be blurred, I'm sorry, but so this is the input. You give the input. You can see that there's no voltage source over here or no power supply. So this circuit contains certain thermal noise. So this thermal noise acts as input for the circuit and produces sinusoidal output. And a part of the output goes through the feedback. So when it goes through the feedback, there's a phase shift of 180-degree. And when it goes through the amplifier, there's a phase shift of another 180-degree. So it's a total of 360, which makes the input and output in phase. RC phase shift oscillator is used for generating signals power, a wide frequency and range. The frequency can be varied from few hertz to 200 hertz by employing one set of resistor with 3 capacitor ganged together to vary over a capacitance range in the 1:10 ratio. The frequency of oscillation is determined by the Burghausen criteria, which says that the circuit will only oscillate at frequency for which the phase shift around the feedback loop is equal to 360-degree or a multiple of 360-degree, and the loop gain is equal to 1. So an oscillator must satisfy the Burghausen criteria. So what the Burghausen criteria says is A, that is the gain and or the voltage gain, and B, or beta, and that's what we refer to. So the product of A and beta should be equal to 1. And the phase difference between the input and output should either be 360-degree or 0. If a circuit satisfies these two conditions, then you can say that the circuit is an oscillator or an RC oscillator. That's it for this video. Thank you.